Welcome everyone. This is our special week of Hannover Messe. We are this week co-hosting special editions of our normal show, a little bit different timing, and we are co-hosting with IIoT-World. So this is Industry 4.0 Club of Hannover Messe. Good morning, good afternoon, good evening, everyone. We are here at 11:30 Eastern, and over in Hanover it is 5:30 European time. I am joined here with Ira Sharp, my normal co-host, and in our Industry 4.0 cohort, and also joined by Lucian Fogoros from IoT World, and our special guest today is Karsten Heuser. So before we start this session today on LinkedIn Live, just a little bit about ourselves here, and then we're going to start talking with Karsten. If you have any questions on LinkedIn, please feel free to post your questions on LinkedIn, and we will then pull these forward here to the conversation, and have a great conversation here. So my name is Jan Pingel. When I'm not here with these great, interesting people, I am working for Ingersoll Rand on my day job. I am a product leader for our digital solutions, where we utilize IoT to make our equipment smart and connected. Ira, over to you.
Thanks a lot, Yen. So my name's Ira Sharp, and I love being part of the Industry 4.0 Club and talking about the future of manufacturing, which is our typical Tuesday room with Yen. But my day job is I'm actually the director of marketing for automation products at Phoenix Contact in the U.S. market. So responsible for controls and networking and I/O systems, process infrastructure, lots of different things that can connect together. But truly enjoy learning new things, having different conversations, and expanding on the topic of Industry 4.0, IoT, and really wherever the future of automation is going to take us. And I'm really happy that we're co-hosting here today with IIoT-World with Lucian, and maybe you can give us an overview of who you are.
Sure. Thank you, both Ira as well as uh, um, the club for this opportunity to join you. So I'm Lucian Fogoros. I'm the co-founder of IoT World. Prior to starting IoT World, which was on a mission to democratize the industrial market insights, I was 20 years in industrial software, from development role to product management. And prior to that, which is why tonight is one of a very dear subject, is I spent 5 years in a tool shop. So I'm a tool and die maker. That's how I helped pay for an undergrad.
Okay, very cool. So here today we are in a typical Tuesday manufacturing future room with the topic of typically around what's going on with new technologies, new standards, and that kind of stuff. So very dear to our my heart, at least, is some of these new things that is going on with Industry 4.0, and one of those are additive manufacturing and 3D printing. And so today we have Karsten Heuser from Siemens, who's been on the show floor for a couple of days here, presenting what Siemens is doing, and I'm sure also looked a little bit around at what others are doing there. So Karsten, he's VP of Additive Manufacturing for Digital Industries, and he's also head of the Siemens core technology around this area and has been so since 2017. But he's been working for Siemens for over 20 years, as you say. So when we get to the 20 year, we don't really go into details, but long time and a good time, I'm sure. So, Karsten, if you want to just quickly introduce yourself and talk a little bit about the area that you are responsible for.
Yeah, Jan and Lucian and Ira, thanks for having me. Actually, this is my first LinkedIn Live. I'm very active on social media, but looking forward. Thanks for inviting me into your club. I had 2 intense days now at the Hannover Fair, and yes, you mentioned Siemens additive manufacturing has 2 perspectives. One is we are trying to transform our own business inside of Siemens by using additive for our own products in trains, in smart infrastructures, in digital factories for different kind of areas. And the other aspect of my job position is to work with the external market on the machine builder, on the end customer side, to transform the industry into an industrial use of additive manufacturing. And this consists of software, automation solutions, as well working on complete ecosystem projects to make big and large applications happen.
So when you talk about additive manufacturing and 3D printing, there's various different like use cases. We talked about those. I think we talked with you guys last year as well with Hannover Messe, and we also had various different sessions around this topic. And I think we pulled some of your Siemens guys into a couple of different rooms we had in Clubhouse last year and early this year probably. But if you can just go through some of these specific use cases, I'm thinking here, additive manufacturing is print parts on demand kind of thing. It's also be able to sharing designs. It's also about prototype, be able to very cheaply build something you can test out before the actual production or full run of stuff, right? So what are the different scenarios where additive manufacturing is making a difference today?
Yeah, thanks. And you're already right with the examples you explained. But if I would say from the value driver, additive is a kind of core technology for sustainability. Second is for individualization. Wherever you have individualized products, this is something where additive comes into play, being able to do something you cannot do with other applications and technologies. Number three is productivity on the shop floor. So in all our factories, we use extensively additive to have better trays, better gripper for the robots, and a lot of parts are used to increase productivity. Number four is repair instead of printing new stuff or producing new stuff. And five is more the digital warehouse. So companies tend to work in areas that they don't want to store any more assets in physical shelves. They want to store it digitally, and then whenever you need it, you send a file over to the location and print it locally. This would be the five value driver where additive is a tool, and this can really generate value in these kind of areas.
So 3D printing is pretty clear what it means. When you talk about additive manufacturing, what does the additive word really signify?
Yeah, I would characterize, and I don't care if you say 3D printing or additive manufacturing at the end, but it's the opposite of subtractive. So with subtractive, you're really going from a block and having then CNC milling or drilling or whatever kind of technology. With additive, you start from nothing. You have powder or you have an extruder, and the different materials are built up like in nature, grow up in this kind. And so this means additive, and this can be in house, this can be kind of forms, this can be metal parts, this can be polymer parts. So I myself use as well my eyeglasses, my eyewear here is printed. I have shoes with printed midsoles. So this is now coming as well to the usual user experience of a normal consumer like I am myself. Yeah.
Well, that's interesting. So you say your glasses is 3D printed. Is that just something that you did just to test it out because you guys can do it, or is that just a new consumer trend?
I think this is more than a trend. This is as I mentioned, this is something which gives you a higher sustainability. So by printing the glasses instead of doing this by a classical methodology, you have a 60% lower carbon footprint. So this is already something good for the sustainability. Second aspect is this is not that I printed in a lab or in my cellar or in the company. I just went to the optician. The optician took an iPad, very normal optician in Bamberg in Germany, and he scanned my face. And then I tested different kind of models in the digital world, and he can make an individual eyewear frame for only myself, my face. He pressed on now print button, then this was transferred to the company we're working with. And we're actually supporting this startup company in Munich. And they're running now up to 100,000 of these eyewear frames and scaling very fast, very high quality. And this is, you find a lot of shops, the old pragmatic opticians, where you can go and get this, self-made for you with individualization.
That's a great start of at least an interesting use case that I haven't even thought of that you guys are working with. What are some of the other things that you are talking about at your show floor, new things you're showing that Siemens is doing?
There, and I brought a picture with me here. The big showcase is that this year's partner for additive manufacturing is SLM Solutions. When I started Hannover Fair, my first Hannover Fair was in 2017. It took roughly 7 to 8 days to print a complex metal part. Now, with SLM Solutions, we developed the automation concept inside of a machine working with 12 lasers. And we have been very proud that this was the main showcase. The Chancellor of Germany, Mr. Scholz, was here with the President of Portugal. And you may see here, he has one part in his left and one part in his right hand. And actually, there's the old classic casted part, and there's the additive part, which is bionically optimized, which is 30% lower in weight, and this was the main showcase. And actually, this was the main showcase shown to the German Chancellor here. And here, Cedric Neike, our managing board member, is explaining this to him. And we have a lot of traction, and you see incredible crowd on the booth. I would never have expected this before. After COVID, now the first Hannover Fair, and what happens? Is somebody coming, or how many people are coming? And if you just see on the second picture I brought with me, it's incredible. So in front of our booth are standing hundreds of people. We need to explain additive, and this is really a cool use case, because this is showing that I mentioned it's not taking weeks it's taking 1 day to print this piece, 30 hours, so 1.5 days. And we show the full end-to-end flow until this is brought into a car. And this is very, very interesting. And I brought another picture with me where you see how this looks if it's coming out of the printer. So it's 60 times 60 centimeters, 14 of these knuckles. This is at the end mounted 4 at the wheels of the car, are produced in one build shop here. And then this needs to be separated, cut it off, and finished a little bit. That's how people are interested to look into that. And today, this morning, was explained on the last picture. You can probably share that it's about the ecosystem, and there as well our CTO, Peter Körte, and Cedric Neike, our managing board member, shared with us as well. They're thinking about the ecosystem, and it's only if you openly work together with, as well, sometimes competitor, with customers, with different people in the value stream, you can make this happen to really change the needle to come to scalable and sustainable transformation as well in the space of additive manufacturing. So these are my experiences, but Lucian, you may have your own as well, being here for at least 1 day.
Yeah, to me it was cool. If you go back about 20 some years when I was going to school, like and working as a tool and die maker, just what Karsten mentioned, right? It used to take several weeks, sometimes 3 months, to build a mold, right? And you're talking about building just a mold for a prototype. It worked in air, I guess in the aeronautical space. So the competition was so harsh that it was getting who's building the first airplane, and it would take 3 months to do it, and may cost, let's say, a tool for $250,000. Yet if you're late, you're charged $250,000. So the harsh competition there. So now we can get something like this printed. Maybe a mold for a pair of glasses is not $250,000, but to print it in a day and a half or faster, that's speed to market. And I think that's it has a lot of application they could think of, and certainly, Kirsten showed some in the automotive, but I think about a flight that it's first class, you're landing in Chicago, and you don't have to, if somebody cracks some first class knob or something, and yet you can print it there by the time the flight lands there, and when it goes back, it's like new, because you don't want to sell the same seat to somebody with a cracked door. So there's a lot of application and opportunities there.
Yeah.
So
Go ahead, Ira.
I was just curious. So I mean, this is really exciting stuff, and I love the idea that this is becoming more into the mainstream, particularly with being able to prototype and as well as machine parts, for older types of things that maybe you can't get parts for. But are there any drawbacks or disadvantages to this type of topic? Are there any challenges that come along with it, or is it primarily just a positive step forward in the right direction?
I think there are probably two challenges I can mention. On the one hand side, there's some homework still to be done to the technology guys to have the most efficient use of all the powder and produce it. And you've seen one of the parts that we're working on software to even reduce some of the support structure. So there's continuous homework, and this is, I can tell you, done by all the experts. But then there's a next challenge, and this is that we are now, and this is probably in the industry 4.0, like in any other technology, we are moving in the transformation process now from the innovators, the early adopters. So I probably myself, I'm the early adopter. Whatever I can get as new technology, I want to have it. But then you have a second group, which is a majority, and this is something normally it's called the pragmatists people, or the conservatives even. And just take aerospace industry, a pretty conservative, pragmatic industry, though, to build up the trust that all the quality, all the certification data are used to qualify the process done, to get signed off these parts to use in any kind of aircraft. I think this took quite longer than expected the last years. People overrated the market some 5 years ago because they underestimated the time you need to get this trust level. But in the meantime, I think there's no aircraft in the world without additive parts flying. It started with polymer. It's building the trust that, yes, these parts are sustainable in terms of reliable, quality, withstanding. And now it's moving into the metal parts in the aircraft. And the same happens in automotive. Always, if you start to produce something which you can only produce anymore by additive, and that's making the trick. It's not mimicking to produce the same part you can do by milling with 3D printing. It's producing something you can only produce and design for additive manufacturing. Then the challenge is to get the pragmatists, the conservative people in the factories and the companies convinced of using this. And then it's about scaling. Scaling needs to be investment. So another challenge is the risk of who's taking the risk on the production. You need to invest into factories with additive before you know that you really can sell 100,000 of these pieces into an automotive supplier. And this is something which I think is very crucial. We are addressing this. For example, for the eyewear case, we have Siemens Financial Service. They're doing the leasing model, the financial model for the factory. So lowering the risk of spending a lot of CapEx versus transforming this in operating expenses. And therefore, we are helping on different angles to really reduce this kind of challenges, which are the hurdles on the implementation.
Thank you for that. Another question I have here is, understanding those challenges and where things are. Looking forward, once we get into more of a larger adoption, do you see this being something that a lot of facilities have on premises, or do you see like a new breed or a new type of integrator or a new commerce model where people are providing the service? Where is this going to be done Is it going to be done at the user, or is it going to be done by a third party or even a manufacturer like Siemens?
I think in the beginning, all the enterprises, they have built up their center of competence the last 5-10 years. The center of competence, you find it in every automotive, aerospace company and so on. They experienced it, they designed the parts, they looked into the certification. But this phase is now coming to the end, that I would assume that the supply industry is now starting up, ramping up on tier 1, tier 2 supplier to make this step into the production. Just recently, you may have heard in US, there was the Additive Manufacturing Forward program launched by Joe Biden. And the aim is nothing more than empowering the supply chain of the big aerospace. Siemens Energy has a lot of supplier. We need to educate. We need to build up the competency, capacity at the supply chain. And then it depends a little bit that we would all assume it's more local. So it's less mega factories. It's more local where you produce in terms of at the place where you mostly use it. So for example, the eyewear factory, they built up the first kind of blueprint factory in Munich area. And now they consider how to duplicate smaller size of these kind of factories around the world. And then we see brownfield, that additive is just a part of a normal production site. Every factory, assuming if you listen to Mercedes or others, would have additive machines somewhere on the shop floor. If you need overnight a new gripper for your robot, you will just print it. So different kind of brownfield, greenfield, but as well small size factories for more localized production will be there in 5 years, and it will be everywhere.
Yeah, it's really exciting. I mean, like how much runway there is, how far this can go, and how widespread it can be into all these different areas. It seems very logical that today the really big users that are dependent on custom and unique machines, you know, like we're talking about here, are the big adopters of it today. But who knows tomorrow? There's a question in the chat here that says, can you apply this topic of adaptive manufacturing to equipment as a service? And does this reduce any adoption risks? So if you couple equipment as a service and adaptive manufacturing together, does this reduce adoption risks? Is this something that's currently being done or being evaluated in any way?
Yeah, I would say yes. Just consider you're an entrepreneur. You have a service company and you have found the part. Now you get the request from an automotive or a different customer if you can produce 100,000 of these parts. What do? You need to plan a factory. This is something we can help them. And then you need to invest. And now it's a big risk on the investment. If you can transfer this risk in an OPEX-based model that you pay as you use the machine, as soon as you earn money with the machine, you pay as well for the machine. This is a big topic to lower the risk as well from the financial perspective. And this happens in some areas as we speak already. Yes, I would say.
So that's, I mean, a lot of interesting areas where this can be applied, and what I'm interested in too is that this is also an area where you see a lot of consumer-based people buying their own little small printer and trying something out. Are you seeing any, like in other technologies, a lot of stuff start with the consumer, then it gets into our space a lot later. But in this case, from a prototype perspective, I think it actually started in the industries, and then now you got the hobby people at home trying it out. Do you see any drivers that where they're going to maybe influence the manufacturing or vice versa on what they're trying to do, but especially around, you know, how do you maintain IP for those files that are floating around that people are printing out from? How do you manage that? You mentioned earlier about the ecosystem. I'd be interested in understanding that a little bit better. How do you see that in the future? Companies sharing information when it's relevant and keeping it for themselves where they don't want to, etc. How's that managed? And
Good point. And probably to answer in two aspects. The first one is these people are purchasing and getting a printer for home. This is very funny. Sometimes I hear companies that the workers do something at home to bring a printed part to work. This is very funny. And this happened as well within Siemens. So I think this is a great example that we need to educate all our workforce. The more printer we have in the world, even if these are very small plastics type of printer for some $1,000, are very useful to get the people curious to try out what they can do with additive, even if you print it for your home. And then they try and bring this into the factories, into the companies. So we did it differently. So we have now a maker space in the middle of the factory in Erlangen, and the workers can go there during work and print something if they need it. But they can as well, after work, do some stuff for private reasons. Here, very small printer, Ultimaker connected with the Cura system to our software. And this really helps to get people build up competence. And just consider how large our workforce is. We cannot wait for the next generation of students. We need to work on the students and schools, yes, but we need to transform the existing workforce, and these are the people between 30 years and 60 years, not being educated in the role of additive manufacturing. And then there was the second aspect is how you treat all this. Yes, I think you need to have playing rules in ecosystems. You need to have clear definition who's responsible for what and who's owning what. So we are having some platforms where this is clear defined that, for example, just take the data, the IP. This is only belonging always to the inventor of the original part. And this is very important that this stays securely. We have solutions like digital right management. How do you can make sure that this is always staying with the inventor and the owner of the part, and then have playing rules on platforms like our AM network, where the supply demand can be combined, but on a secure as well cyber secure way to make this and enable this kind of ecosystem as well with some cloud systems.
Yeah. So, and we probably talked about. I remember last year we talked about NFTs, be able to protect some of that IP. I don't know where that's going to go these days. But one of the things we got about a little bit less than 5 minutes left here. What I'd like to hear from you too is it looks like Siemens is doing a lot of great stuff, and I definitely hear a difference even from last year when we talked at the same time, or was it a little bit earlier? I don't remember, but and I don't think you had those glasses on last year at the same time. So things are definitely happening here. But at the Hannover Messe, what else have you seen, even outside Siemens, where there's something new that you said, okay, we didn't do that a year ago?
So I think the home turf fair for additive manufacturing is probably not the Hannover fair. We just had the Rapid in US, and there will be upcoming next November the Formnext, which is more like the whole additive community is meeting to look which material machine is coming up. So we see more the user, the demand, people here at the Hannover fair, so companies really using this for the machines, for the equipment. I've seen hydraulic components, very great examples here where you can make and save a lot of material for hydraulics. I have seen chemical components for reactors by nanoporosity and different kind of shapes to save energy for the chemical plants. I'm hearing a lot about pharma, so printed medical like cancer treatment, which is personalized to your weight, to your size, to your whatever. This is a trend. I hear a lot about food. You may find companies printing some salmon instead of hunting this and doing this as well as a sustainable. And I hear a lot about printing buildings, construction. Large robotics-driven printers are now available, free form. You can print a parts for windmills, you can print large forms, and you can even print and construct complete houses on that. So these are total different areas in itself. We can speak an hour about these kind of areas.
So Karsten, before we let you go, a couple of weeks ago, I was at an event in Cleveland with one of the co-founder of Industry 4.0, Mike Yost, and he asked me, so what is Siemens' role in this 3D printing? You would help. I mean, my first reaction was like, oh, well, CNC machine. But maybe explain what is Siemens' role in the...
So we really help to transform the industry. So we have 6 additive manufacturing hubs in the world, 3 in Germany, 1 in US, in Charlotte, Catch, 1 in Singapore, and 1 in China. These hubs are full with experts. We can talk on material technology as well on end-to-end use cases. At the end of the day, we earn our money back by having automation inside of the machine, planning factories, and as well selling software for the different kind of design and simulation. So we have the toolbox, but it's not good enough to just sell a toolbox. You need to help on an end-to-end holistic way to solve really mega applications. And by that, you need to give more into the ecosystem than just your products.
Yeah, that makes a lot of sense. This has been a great conversation. I think we rounded this area very well, going in all kinds of different directions. But before we go, just want to know here for everybody that's listening, where can they find you at Hannover Messe this week here for at least the next 2 days?
I think the Siemens booth is something like the most impressive. It's in Hall 9 here. But as well, you find me under the club here. I think you can get my contact on LinkedIn. So just send me a note. We will find a way how to contact virtually or real during the week. I have a team here on the booth helping as well. We have our partner here. So different kind of experts here. But in Hanover, it would be in Hall 9. And then there's no way around that you will find Siemens at a booth.
You may also find a couple of sessions online with Siemens Hannover. So at least for the next 30 days, they'll be available, a couple of sessions on the 3D printing as well. We'll post them in the comments.
Well, thanks. Thank you very much, Karsten, for joining us today. And thank you, Lucian, for giving us the opportunity to join together with you guys and have these interesting conversations. This is not the last one. We have 2 more. We have one coming tomorrow at the same time, 11:30, and one on Thursday as well. And just to verify, I believe I had that one tomorrow is with Rainer Brehm, who is the CEO of Factory Automation, also at Siemens. So please feel free to join us tomorrow at the same time for another great conversation about what's going on at Hannover Messe and what's new in factory automation. And with that, thanks again, everyone, for joining us. Hope you had a great time like us and learning a lot about additive manufacturing and 3D printing. And feel free to keep following both Industry 4.0 Club and IIoT-World. We both have sessions on and off on these topics and other similar topics that are always going to be interesting, especially if you're interested in manufacturing and Industry 4.0. So with that, thanks, everyone. Thanks, Ira. Thanks, Lucian. And especially thank you, Karsten, for joining us today. It's been great fun.
It was a pleasure having me. So Lucian, Jan, and Ira, have a great day. Goodbye.
Same to you.
Cheers. Bye.
Okay.